Welcome back. The objective of this video is to fit data in and create a logarithmic regression model. In example 8, we are given a table with data. So we will put this data into our calculator in list 1 and list 2. So we'll go under the stat menu, we'll go into edit, and then enter the data into list 1 and list 2. So list 1 will be our x's, list 2 will be our y's, and then it asks us to determine the equation of the logarithmic regression. So once we've got the data into our list, we could create a scatter plot if we wanted to and set our window between like 0 and 10 for x's and 0 and 10 for the y's. We could probably use the standard window for this as well, and then plot the data using the stat plot on our calculator. And then in question A, it says determine the equation of the logarithmic regression function. So we go back to the stat menu, hit stat, calc, linear regression, and we'll store the equation as y1. We'll hit calculate and enter. So these are processes we've done before, and this will create this this logarithmic regression. And we chose natural log regression. That's the one I would recommend choosing. And we get this particular equation, and that'll be stored in y1. And in question B, it says use the function to predict f of x when x equals 10. So 10 is going to be our input. So we can put 10 into the function and have our calculator do the work, or we could graph our equation and do value x equals 10 as well. So here I have our logarithmic equation. I'll graph that in the standard window. I don't have my plots on, so you can't see the data, but then just to calculate the value at x equals 10, so second calc, and we get 8.07 for our y value. Question C says, what is the residual for the data value at 4.5? So the 4.5 is an actual data point. So what we need to do is we need to do value x equals 4 to see what our trend line comes up with and see what the difference is. So we go back to our graphing calculator and we'll do a value of 4. So I'll go second calc value x equals 4 and enter, and we get 3.805. So our trend line has a value of 3.8, where our actual data set has a value of 4.5. So 4.5 is going to be a y value above this, so we're going to have a positive residual here. Our data point is up here somewhere, and our trend line underestimates that actual data. So we'll do a little subtraction, that 4.5 minus 3.805, and we'll get our residual value. So going back to our data, we got 3.8058. We subtract that from the 4.5 and get a positive 0.6942, and that is our residual for that particular data point. In example 9, it says the table below represents the speed of a coxed 4, a rowing boat used in the sport of competitive rowing. So we'll enter again our data into list 1 and list 2. So we'll go to stat, edit, and I've entered that data into list 1 and list 2. Next, we want to determine the equation of the logarithmic regression function. So I'm going to go back to my calculator. Hopefully I'll get this regression. I could do a stat plot of that. Why don't we go ahead and do that first. I'm going to do zoom standard. I'm already in the standard window. I'm going to turn off this first equation. I'm going to go and turn my plots on. And we'll go to second stat plot. Plot 1 is drawing from list 1 and list 2. That's what we want, and it's on. I'm in the standard window, and there are my data points for sample 9 and our crew of 4. So I want to find my logarithmic regression equation. So stat, calc. I'm going to do a logarithmic regression. That's number 9 on mine. I'm going to draw from list 1 and list 2. I'm going to store my regression equation in Y2. And calculate my equation. And I get 1.5412 for A and 2.559 or 8 for my B value. And here it is stored in Y2. I graph that. The data fits nicely through my data points. So I enter that in my notes. It asked me to find a linear regression model for the data, so I could repeat that process and go stat, calc, and then a linear regression. We'll do 4, looks like slope-intercept form. We'll do list 1 and list 2, and we'll store it as Y3. We'll calculate our regression, and we have a slope of 0.789 and a y-intercept of 1.5, and we graph that, and there's the black line is our linear regression. Question C says, determine which model fits the data better, explain why. The log model, and I would probably write that as ln, the natural log model, is best. Output values are increasing at a decreasing rate. The residual plot is closely aligned. We didn't do the residual plots, but if we chose to do that, we could see that the residuals are going to be much better for the natural log function than they are for the linear function. Question D says, use the best model to find when f of x equals 8. So what I'm going to do here is I'm going to graph y equals 8 along with my logarithmic model. So I go back to my graphing calculator. I am going to turn off the linear. I'm going to graph y equals 8, and I will go ahead and graph. It looks like my intersection is outside of my window, so I'm going to expand my window a bit to go out to x's out to about 15, and hopefully that's going to be enough to show the intersection. It is. And now I can go second calc, intersect, 1, 2, 3, and I see that my logarithmic, my natural log function, and y equals 8 intersects at 12.484. So that means when I have a speed of 8, it will take about 12.48 minutes to get up to that speed. So the bolt will reach a speed of 8 meters per second at about 12.5 minutes. And that wraps up this video on using tables and creating logarithmic regressions. And we'll get some more practice with this when I see you in class.